Welcome to Infinity with Vijay. In this video, we are going to learn about one theorem which is related to the chapter circles. Theorem which says the tangent at any point of a circle is perpendicular to the radius to the point of contact. What and all they have given the tangent at any point of a circle. So let us give a circle with center O. Let us name that center as O, and a tangent, let us name that tangent xy to a circle at a point P, and let us draw a radius OP. Let us name that radius OP. Okay. To prove what we have to prove with radius OP. To prove this radius OP is perpendicular to xy. First, take a point Q on xy, on this tangent xy, other than this P, and join this OQ. Okay. So join this OQ. Okay. Let us write that. Take a point Q on xy, on tangent xy, other than P. Next, what we have to do? Join OQ. We have joined here. Since this point, what we have took, that is Q, it should stay outside of this circle, correct? Q must be lie on outside of the circle. Why? If Q lies inside the circle, if this point Q lies inside the circle, then it will not become a tangent, correct? This line xy will not become a tangent line. It will become a secant, correct? So it is, which is not we want, correct? That's why we want the tangent, correct? So we will take this point Q outside of this circle. So what will happen then? It should, we will write that since the point Q must lie outside of the circle. The reason I have told, why? Because it will not, this xy will not become tangent, it will become secant, correct? So Q must stay outside, correct? So therefore what will happen then? OQ, it must be longer. Q is longer than the radius OP, correct? So OQ, the line, this what we have joined, this OQ must, which is longer than the radius OP of this given circle. So therefore, how we can write? OQ is greater than OP, correct? So what will happen if we took any points, each and every points on this xy, tangent xy, except this P, all will stay outside, correct? All will lies outside of this circle. So if all points lies outside of the circle means what will become? All whatever we will line drawn from this point, maybe if we draw a line from this point O, center O, then all must be greater than this OP, correct? Greater than this radius OP, correct? So what will happen? We can say this OP is the shortest distance. OP is shortest distance from the point O, correct, of the point O to the points on this to the points on this tangent, huh? XY, correct. So what is the reason? I told what is that, since for every point XY except the point P, the point XY except the point P lies outside of the circle, correct. So all this lies outside of the circle. So it means what? OP is the shortest distance of the point O to the points on the tangent line, that is XY. So what we can say? OP is perpendicular to XY, the tangent XY. What we want, what we require, we have proved. OP is perpendicular to the tangent XY. I hope you understood this. What and all they have given? They have given a circle with the center O and the tangent XY to the circle at a point P. So, and with the radius OP. We will draw the point, we will this join this OQ. First we will put a point Q on a tangent XY except this point, and we will join this OQ. Then what will happen? We will use the condition, if points present outside of this circle, then OQ must, that should be, that joining line should be greater than the radius OP. So what will happen if whatever lines we took outside of this circle except the point P, all the points which lies on this tangent XY will be greater than this OP. So OP is the shortest distance. Shortest distance means we can say that OP is perpendicular to XY. We have proved, hence proved. So I hope you understood this. If you have any doubts, please put on comment section. Thank you for watching.